we're starting section 15.2, double integrals over more general regions. First, we do integrating over horizontally and vertically simple regions. Then we reverse the order of integration. Then we integrate over more general regions. So double integral over arbitrary regions. For a rectangular region A, R interval A and B times interval CD, the double integral over region R of function f of x and y can be calculated as an iterated integral. So it can be written as integral a to b, integral a of integral a, c to d of function f of x and y dy dx, or the other way around, integral from c to d, integral from a to b of f of x and y dx dy, where the inner integral represents a slice of R as a fixed value of x or y. We saw those slabs that they were building up. So each inner integral is the area of that slab, and then you integrate over all the slabs in there. Now, the slabs were all, they all have the same width because there was a rectangular region. Now, when in general, suppose D is an arbitrary region in R2, how do we calculate the integral over d of f of x and y dA as an iterated integral? So you're kind of expecting the same thing, just the slabs are not going to have the same width. So let's look at this. Simple region. When possible, slice D into vertical or horizontal strips. And so that's the, and over here in vertically simple strips, and so you basically, you find the integral over those vertically simple strips, and that gives you an area, because it sticks out to z direction, right? And it gives you area, and you're adding all those areas because each area is basically tells you an infinitesimal volume, because the over here the width of each strip is delta x, and it's basically infinitesimal, and that width times the height times the area gives you the volume every time, infinitesimal volume. And so it goes all over. And same thing for basically when you have integration over with horizontally simple regions. And so you basically, if it's possible, that's what you want to do first. So when you're doing vertically simple region, you basically taking the inner integral is f of x and y from g1 of x to g2 of x, and the variable that you're taking integral with respect to it is y. So x is basically constant in there, and then the outer integral is from a to b, and that's with respect to x. When you're doing the horizontally simple regions, the inner integral starts with h1 of y, goes to h2 of y, and f of x and y in with respect to x, and then the outer integral is with respect to y and goes from c to d over here. The inner limits are functions of outer variable. Outer limits are constants. Those are important to remember, basically. Now I click here question 15.2a. Which of the following expression does not make sense? A bunch of integrals are given according to the information that we got last time. We want the outer bounds of the integral to be constant, and we want the inner bounds of the integral to be constant with respect to the outer variable, whatever the outer with respect to inner variable. And so we want them to be basically a function of outer variable. So let's stop and think about it for a minute. So I hope you stopped and thought about it for a minute. And so look at this. Over here, I have both of the integration limits to be constant. So that's completely possible and legal and can happen. Over here in B, I have basically the outer constant, the inner is a function of x. And so over here, because we're inside is the with respect to y, the integration bounds are supposed to be constant with respect to y, and they are. So this is okay too. Over here, the inner is with respect to y, but the bounds are not constant with respect to y. So this is not right. And you can check the last one also. It's with respect to y, but the bounds are constant with respect to y. So D is the answer.